But the usual response of orthodox evolutionary biologists to all of this is, well, yes, there is epigenetic marking of the genome, but it doesn't get passed on through the generations, and when it does, it rapidly dies out. Well, it doesn't always. This is from a lovely study published in Cell by Harvey and his colleagues looking at the nematode worm C. elegans, in which they investigated the mechanism by which the worm can respond to a viral invasion. There are not many, excuse me, there are not many viruses that can infect nematode worms, but this particular one triggers an RNA-dependent viral silencing response. And what they did was then very clever. They took worms from that population and crossed them with wild type C. elegans, some of which would have the DNA to make that RNA and some of which do not. And then as you go down through the generations, of course, you will eventually end up with some worms that have the DNA and some that do not. But they will all be offspring from worms that had the acquired characteristic. They all inherit the viral silencing response. And Harvey and his colleagues show exactly how that is done. RNAs are going down through the germline, and the response is therefore transmitted across the generations, and it is amplified by RNA polymerase. So although you transmit only a small quantity of RNA down through the germline, you amplify it up so that every generation, they followed this for 100 generations. It dies out? No. It does sometimes. And moreover, I think that epigenetic mechanisms that show transience are an advantage in evolution. You can see why, because it gives the organism, excuse me, it gives the organism the possibility of experimenting with an environmental challenge, but then, as it were, working it out. Is it worth going down that pathway or not? It's reversible, that's the point. But sometimes, as you can see, it can go down through many generations. Now, why is this important? Not only because of demonstrating the transmission through so many generations of a non-DNA inherited mechanism, and remember it was an acquired characteristic in response to viral invasion, it's also precisely what Charles Darwin foresaw. Darwin was a Lamarckian, and many people don't know that. In The Origin of Species, and this was pointed out by the great orthodox evolutionary biologist Ernst Mayr in his work in 1982, a seminal piece of work, but very much within the orthodox neo-Darwinist mold. There are at least 12 places in The Origin of Species where Charles Darwin points to the inheritance of acquired characteristics. He'd never criticized Lamarck on that particular issue. Indeed, he praised Lamarck in the preface to the 4th edition of The Origin of Species as this great biologist who championed the transformation of species.